All right, so for this, we're just going to look at some basics of similarity. And we've already looked at similar polygons, so a lot of this should be review. And what you should remember is that the angles of similar polygons are always congruent, the corresponding angles, the ones that match up with each other. And you can see it here, like we have this green angle, it's congruent to the green one. We have this orangey red color, congruent to this orangey red color. And then, oh look, there's a yellow there, I didn't even see that, I just thought it was blank. And the yellow is congruent to the yellow. So there we go, we have those angles congruent to each other. And the sides of similar polygons are, remember, they're always in proportion. So there's always a scale factor going between these things. So what we're going to do now is we're going to find the lengths of sides x and y. But importantly, what we're going to do is we're going to use these angles, the placement of the angles, to actually match up which side matches up with which side. So I'm going to start off with, I'm looking at side AB. I'm going to label side AB in black, and the color is going to become important later. And you see how AB is between the orangey red and the green? So that matches up with the side in between the orangey red and the green on this triangle. Cool. So next, if I look at side BC on the larger triangle on the left here, I'm going to label that in red. That goes between the green and the yellow. So that matches up with the green and the yellow over here. And then finally, the last side, which I don't necessarily need to label because it's already a different color, but whatever, we'll make it different blue. AC between the reddish and the yellow matches up with DF between the reddish and the yellow. So here's how we're going to find the lengths of the sides x and y. We can set up a proportion, and super importantly with these proportions, we have two sides that actually have their values. So we're going to use those to start. And I'm going to start with, I'll start with the left triangle on top. So we have 6 over 4 equals. And if I want to find, say, x is this red side here, and this red side here, what we have to do is just set up a proportion. So with this thing, we started with the left triangle on top before. The 6 was on top. So we got to start with the left triangle again, put 7 on top. And then put the right triangle is x. So now all we have to do to solve for x, which I'll keep doing it in red, is cross multiply. So we have 6 times x is 6x. And then we have 4 times 7 is 28. And then from here, divide by 6. And we get x equals 4 2/3, or 4.66666, blah, blah, blah. So to solve for y, we're going to do the exact same thing, basically. We're going to start with our known proportion here, 6 over 4. And if you wanted to, you could use 7 over 4.66666, but that's kind of annoying because of all the decimals. I'm just going to keep it with 6 and 4 because that's pretty clean and easy. And then this should equal, the right side is 8 over y. So we got 8 over y. And then what you do is you cross multiply again. So we get 6y equals 32. Divide by 6. And you get y equals 5 1/3, or 5.333333333. So to recap, between the two angles that match up, those sides correspond to each other. You can use this to create a proportion, like this. And then, from the proportion, once you have it all set up, there should only be one variable in that proportion, otherwise you can't solve it. And then you cross multiply, and you solve for x, y, whatever your variable is.